Welcome to Physics Dream Team Classroom, College Matrikulasi Pahang Kementerian Pendidikan Malaysia.
For today's lesson, we're going to learn on Chapter 7, which is on gravitation. Let us look at an overview for the lesson. In gravitation, there are 4 subtopics that we're going to learn, where they are: the first one is Newton's law of gravitation, the second one is gravitational field strength, followed by gravitational potential energy, and the last one will be satellite motion. We begin the lesson with gravitational force and field strength. From Newton's law of gravitation, it states that a magnitude of an attractive force between 2 point masses is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Or in mathematical equation, the force acted by mass 2 on mass 1 is equal to the force acted by mass 1 on mass 2, which is equal to gm1 m2 per r square. Please bear in mind, the gravitational force always attractive in nature, and the force always acts along the line joining the 2 point masses. Gravitational field strength. The equation to find gravitational field strength is Ag equal to gm per r square. It is a vector quantity. The SI unit for gravitational field strength is Newton per kilogram or meter per second square. Sometimes, gravitational field strength is also known as gravitational acceleration or the free fall acceleration. The direction is the same of directions of gravitational force. Look at figure 1. It shows the directions of the gravitational field strength on a point at distance r from the center of the planet. If the test mass is at the surface of the Earth, gravitational field strength is equal to gm per r square, where the r is the radius of the Earth. If the test mass is away from surface of the Earth, and equations of gravitational field strength is gm per r square, where r is the distance from the center of the Earth to the point. Now, let us look at gravitational potential energy U. Gravitational potential energy can be defined as the work done by an external force in bringing the test mass from infinity to a point. The gravitational potential energy at a point in gravitational field is equal to negative gmm per r. Figure 2 shows the variations of gravitational potential energy when the test mass moves away from the Earth's surface. It shows the gravitational potential energy is decreasing with increasing distance r. If the test mass at the Earth's surface, the equations of gravitational potential energy is negative gmm per r, where r is the radius of the Earth. Please take note that the gravitational potential energy at infinity is 0. Satellite motion in a circular orbit. We start with escape velocity. What is escape velocity? It can be defined as the minimum velocity required by a mass to escape completely from gravitational field to infinity in outer space. Escape velocity equal to square root of 2 gm per r. If the test mass on the Earth's surface where the distance is equal to radius of the Earth, hence the escape velocity will be square root 2 gr. Let us continue the lesson with another type of velocity where it is tangential velocity. Consider a satellite of mass m traveling around the Earth of mass capital M with radius capital R in a circular orbit of radius r with constant tangential speed as shown in figure 3. The centripetal force Fc is contributed by the gravitational force of attraction F exerted on the satellite by the Earth, where F equal to Fc. Hence, the tangential velocity V is given by the equation below. V equal to square root gm per r. For a satellite close to the Earth's surface, the equations of tangential velocity is square root gr. Period of satellite motion. The relationship between tangential velocity and angular velocity is V equal r omega equal 2 pi r per t. Hence, the period of the satellite orbit around the Earth is given by t equal to 2 pi square root r cube per gm. Let us continue our lesson by synchronous or geostationary satellite. In figure 4, it shows a synchronous or geostationary satellite which stay above the same point on the equator of the Earth. The satellite have the following characteristic. The first one, it revolves in the same directions as the Earth. The second one, it rotates with the same period of rotation as that of the Earth, which is 24 hours. Then it moves directly above the equator. And the last one, the center of a synchronous satellite orbit is the center of the Earth. This satellite commonly used as communication satellite. To understand more about this chapter, let us try this simple exercise. Exercise number 1. Two objects of mass m1 and m2 are at a distance r apart. The magnitude of gravitational force between them is. The answer will be B, because it's stated in the Newton's law of gravitation, where from Newton's law of gravitation, it states that the magnitude of an attractive force between 2 point masses is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. We proceed with exercise number 2. What will happen when an object is raised from the surface of the Earth to a height of 3 Earth radii above the Earth? From equations of weight is equal to mag, where ag is gravitational field strength and ag mathematically equal to gm per r square. It shows that the AG and R square is inversely proportional. When the height is raised to a greater height, the AG will decrease. Hence, the weight will decrease. So the answer for exercise number 2 will be D. See you again in the next chapter. Enjoy your day.